Hello students, welcome to Go Vidya and a series of 1000 questions in TRANSCO GENCO. So as we are starting the control system questions, and we have seen like a lot of questions based on the various topics like block diagram, time domain specifications, RH criteria and root locus, and few more problems are there in series of control systems questions. We will see one by one. Now let us see this question. So in this question, if you see, they have clearly mentioned the Routh-Hurwitz array of third order characteristic equation they have given, and its corresponding root locus also they have given. Now what is they are asking is, what is the value of k and c? This is the value they are asking. So for what values they have given coefficients? For A, B, C, they have given A value, but we don't know B and we don't know C. Okay, so what they are asking, K and C, like from the characteristic equation K and this C they are asking. Anyway, A they have given, B we have to find out, but we will see how to find out that. Okay, now what is the condition they have mentioned? Indirectly they are saying that yes, the point of intersection is existed on this imaginary axis. If you observe very carefully, point of intersection is existed on the imaginary axis. That indicates the system is critically stable. For the critically stable condition, what we are going to do? We are going to equate s power 1 rho to 0. So if I equate s power 1 rho to 0, then how to write that equation? From RH criteria, we know very well, 6 minus k by 3 equated to 0. From this, the k value is going to be 6. The k value is going to be 6. Yeah. Now, on the other hand, we can find, or we have to find the value of C. Okay, that is one of the main objective. But as per the question, K we already found, we got the 6. So either option A can be correct or option B can be correct. So any one can be correct. So let us see which one is going to be correct. As per the question, you have to see the root locus diagram. In this root locus diagram, you see that plot is intersected on the imaginary axis at 1.414, which is nothing but what? Can I say root 2? Which is nothing but. So therefore, the critical point for this, that I can say, like, is it a frequency of oscillation? Yes. Can I say the frequency of oscillation from the root locus diagram? The frequency of oscillations is equals to root 2 radians per second. Why? Because J omega axis, we have omega value is 1.414, J 1.414. Now we know the formula from the characteristic equation. By using RH criteria, we developed one shortcut. What is that? We have, for example, let us, this is the third order characteristic equation, s square plus s cube plus s square plus bs plus c equal to 0. From that only I am taking. I told you, if you remember, whenever if you have a third order system, the frequency of oscillations can be calculated. How? The frequency of oscillations can be calculated as square root of the constant divided by coefficient of s square. If you remember, I told you very clear. So can you tell me what is the omega value? Omega value got root 2 is equals to square root of c by, what is coefficient of s square? A. Correct, na? So now from this I can square on both the sides. What I will get? I can get 2 is equals to c by a. But as per the question, they have mentioned already what is the value of a. What is the value of a? A is equals to 3. If I substitute a value is equals to 3, then I will get c is equals to If I substitute A value is equals to 3 here, then C is equals to, I will get 6. So therefore K is equal to 6 and C is equal to 6. Therefore option A is correct and option B is wrong. A is correct and B is wrong. So this is how, see, the question pattern is so easy. One part they have given as RH criteria, another part they have given as root locus. Here what is the trap they have given is the point of intersection on the imaginary axis they have given. Immediately we have to recollect that it is a marginal stable condition. So then only we will get the frequency of oscillations. So once you got the frequency of oscillations, so from this we know RH criteria, third order shortcut. I told you what is that coefficient, constant by coefficient of S square under root, and finally you got the value of C. Okay. So now let us see another question. Now read the question properly. Which of the following plots is the root locus plot for the open loop transfer function given as? What is the transfer function, open loop transfer function? Can I say g of s is equals to 1 upon s power 4 minus 1? Is it looks like, I mean the system has only poles. How many poles it has? 4 poles. Can I write this is like this? S square plus 1 into s square minus 1. Why? A plus b into a minus b is equal to a square minus b square. A square means s power 4 minus b square means 1. Correct now? So again if you see from this, can I calculate the poles like this? From this calculate the poles like this, s square plus 1. I just want to know the pole location. S square plus 1 equal to 0, because I want to calculate the poles, then only I can look at the poles. That implies S is equals to plus or minus j omega, imaginary roots. On the other hand, what we have, s square minus 1 equals to 0, that implies what is the s value? Plus or minus 1. Can we say that? 1 go this side, under root means plus or minus 1. Yes. Now how many roots are there? 4 roots, which are nothing but all are poles only. This is j omega axis and this is the real axis. On the real axis you have one is at minus 1, another one is at plus 1. What about here? Similarly it is also have, can say it's like yeah, what is this omega here? Sorry, 1, j1. Okay na? So one is at 1 j omega, another one is minus 1 j. Now if you observe all the 4 options are looks like similar only. So but which of the plot is going to correct? For that we need to identify one thing. What is the root locus region? If I know the root locus region, I can straight away eliminate few options. See, in this root locus is inside, it is outside, it is inside, it is also inside, but some of them are going away, some of them are coming inside it. So identifying the root locus region will give you some clarity on this solution. So you know that how to find out the root locus region. Hold the rightmost, whether it is a pole or a 0. Hold it and check how many poles and zeros are there. If sum of poles and zeros are odd, then only the root locus region will exist. So if I hold right side, nothing is there, so there is no root locus region on that side. Now if I hold on this imaginary axis, yes, if I hold on this imaginary axis, right side I have only one pole, which is odd. So definitely can I say this is one of my root locus region. This is my root locus region. After that I have to hold this. If I hold this, the sum of all the poles and zeros together is 3, which is also odd. So therefore another root locus region this is also. So that means between minus 1 to plus 1 I got the entire root locus region, because if you go this side nothing is there, there is no pole, no zero, then you cannot identify the root locus region. So therefore can I say our root locus region is between these two. So in such case, out of 4 options, which option can we eliminate straight away? So can we eliminate this option? You can eliminate, right? Yeah. Along with that, you need to understand one thing. Here, plots are showing some directions. So you need to identify the angle of asymptotes also. If you find the angle of asymptotes, then we will get the clarity on it. So I have added a page. Now let us go to the next page. What is the equation we got? 1 upon s power 4 minus 1. That implies, can you tell me how many poles are there here? Number of poles are equals to 4. How many zeros are there? Number of zeros equals to 0. Therefore, how can I calculate the angle of asymptotes? Angle of asymptotes, you can say angle of asymptotes theta L is equals to, what is the formula? 2q plus 1 by 2q plus 1 whole divided by p minus z into pi. Either in radians or degrees we can mention that. So can you tell me what is that? So how many asymptotes are there? 4 asymptotes are there. P minus z means 4 asymptotes. Therefore 4 angles we will get. What is the each angle? Theta 1 is equals to 2 into 0 plus 1 by 4 minus 0 into pi. Theta is equals to 4 means it will start from 0, 1, 2, 3. Right. So what is this value finally? Pi by 4. Similarly, if we calculate theta 2, theta 3, theta 4, 4 asymptotes. That means 4 zeros are at infinite. So theta 2, how can we calculate? Put 1 here. If I put 1 here, tell me 2 plus 1, 3 by 4. So it is nothing but 3 pi by 4. Another one, put 2. 2 if you put 5 pi by 4. Put 3. So these are the values. Pi by 4, 3 pi by 4, 5 pi by 4, 7 pi by 4. Now go back to our actual question. So from this we can say, yes, within this root locus region only, my poles will try to move like this. Poles will try to move like this. Poles will try to move like this. Yes, but they are going to find their zeros at infinite. But what is the angle of asymptotes? One is at pi by 4. Pi by 4 means, can I say this direction? Pi by 4. Another one is 3 pi by 4. Another angle is 5 pi by 4. Another angle is 7 pi by 4. These are the angles we got. Now poles will go in this direction only. Therefore, which option is correct? Option D. See you here. Poles are coming like this. Poles are coming like this on this root locus region and they are moving away in this particular angle of asymptotes. Therefore, option D is correct. Okay. So how we have solved this problem? First of all, we identified all the root locus regions and then what are their pole locations. But unfortunately, the pole locations, they are included in all the options. But only the crucial thing here it is, what is the root locus region? In that region, how the poles are moving, we have to identify. As per that, we got the option D as correct. Because angle of asymptotes are very important in this. Without that, there are 3 possibilities and you can't decide like which is the correct one. Okay. So please take the solution. So till now we have seen certain questions related to the entire time response. What are the time response questions we have solved till now? Block diagrams, time response analysis like time domain specifications, the steady state errors, and then RH criteria we have seen, different conditions we have seen, and then root locus, what is the condition for root locus, and all the problems related to the root locus also we have solved. Now what we are going to see? We are going to solve now series of numericals based on frequency response analysis. The problems which are continuously now we are going to solve, those are frequency response analysis. Frequency response analysis. Frequency response analysis. What do you mean by that? So as we have studied already in frequency response analysis, how the system is going to respond for a sinusoidal input. So what are the changes you are going to observe? One is magnitude, another one is phase. Only those two are going to face the changes. Okay. So now we are going to understand certain numericals related to that, like from the basics onwards we are going to start. After calculating the basics, and we will go for gain margin, phase margin, Bode plot, Nyquist plot, polar plot, all we are going to see. Once it is over, we are going to solve the numericals based on compensators and controllers, lead lag compensators, lag lead compensators, and then KP, KD, KI, proportional controller, derivative controller, integral controller, PI controller, and after that the special method called state space we are going to see. So now let us see this question. Find the steady state output they are asking. What is meant by steady state output? So input is what? X of t is equals to 2 cos 2t plus 15 degrees. And what is the transfer function they have given? 10 upon s plus 2. I told you for frequency response analysis we are going to have only two changes. One is with respect to magnitude, another one is with respect to the phase. First calculate the magnitude and then phase. Then we will see. So first of all, represent this, let us say this is g of s, let us say. In frequency response analysis, any problem you take, please try to put all the time s is equals to j omega. Then proceed further and calculate the magnitude and then phase. First calculate that. Later on, go to the question and what they are asking. From that you identify it. Okay. So now, in place of s, I am putting j omega. Put j omega 10 by j omega plus 2. Okay. From this. First one I am going to calculate. So let me take. Okay. First one I am calculating the magnitude. And this side I will calculate phase. What is the magnitude here? Magnitude of g of j omega. Magnitude of g of j omega is called what? 10 by omega square plus 4 under root. Is it correct? 10 by omega square plus 4. Now, at which frequency the input is given? This is what called frequency. This is what called frequency, omega. So therefore, at omega is equals to 2. What is the magnitude, sir? Let me call this magnitude as m. So what is m value here? 10 by root of 2 square plus 4, which is nothing but 4 plus 4. In plus omega put this. How much this value? 10 upon root 8. 10 upon root 8. Similarly, phase phi of j omega. From this, how to write that? Minus tan inverse of imaginary by real, na? That is how we are going to calculate the phase. So now at which omega they are telling? Omega is equals to 2, na? So for this omega is equals to 2, what is the phi value? Minus tan inverse of 2 by 2, which is nothing but 1. Tan inverse of 1 means 45 degrees, na? So anyway minus is there, I kept the minus. So at frequency 2, what is the magnitude change I observed? 10 by root 2 8, and phase is minus 45. And finally what we need to do? We need to put into the equation, what is that? Y is equals to, or y of t. Let me take y of t. Y of t is equals to, anyway initial magnitude is 2 is there. 2 into a cos of 2t plus 15 degrees plus phi. Plus phi. This is what the change we are going to observe, because frequency response analysis means when I give a sinusoidal input, I will be getting a change in magnitude and a phase. This is the representation as per this input with respect to the input. See, there is no change in the output shape. Only change you will observe with respect to the magnitude, that is nothing but scaling, and the phase angle, that is nothing but the shift. Phase shift only we are going to observe. Rest everything is same. And it will never affect the change in frequency. So now you put 2 into 10 by root 8, that is nothing but 20 by root 8. 20 by root 8 cos of 2t, it is plus 15 and phi is minus 45. Minus 45 plus 15, which is nothing but minus 30 degrees. This is what the steady state output. This is what the steady state output. For which input? Sinusoidal input. So for sinusoidal input at steady state only you are going to observe what? Change in magnitude. Change in magnitude. Yes. Change in magnitude you will see, and change in phase you are going to see. These are the only two things we are going to observe. Okay? So please note it down, this question. In this question, if you see a system with the transfer function, they have given s by s plus p. Let us consider the transfer function as g of s is equals to s by s plus p. Has an output, okay. For this transfer function, they have given output also, okay. Directly they have given. What is output? Y of t is equals to cos of 2t minus pi by 3. 2t minus pi by 3. So strictly speaking, this output is which output? It is a steady state output. For steady state output, what are the only changes we are going to observe? One is with respect to magnitude, another one is with respect to phase. So here magnitude is how much for this? For this, can I say magnitude A is equals to 1 from this? And from this, what is the phase? Minus pi by 3. These are the only two changes we observe. Now, they have given input also. What is the input for this particular signal? Can I say input for this particular signal is P into 2t minus pi by 2. Okay. So, we have to get what? A into P must be equals to 1 na? Because this is the steady state output. Right? So this steady state output 1 I have to get. In that case, my standard notation A and product of that input P. So if I got those two products, I will be getting that 1. How to calculate this A? Simply A is nothing but what? Magnitude, na? How to calculate the magnitude? You put here. Put S is equals to magnitude, M is equals to, put S is equals to J omega. I told you. Put S is equal to J omega. In entire frequency response analysis, you do that, and you put the magnitude here. At where? Omega they have given 2. Correct na? 2. So now omega by root of omega square plus p square at 2. At omega is equal to 2 na? So can I write it like 2 by 2 square plus p square na? Under root. Now this is what? This is also called at A, magnitude. Now AP is equals to 1, coefficient. AP is equals to 1. So now can I say this from equation 1? Can I say 2 by root of 4 plus p square multiplied by what is this? This is p equal to 1. Now squaring on both sides, 4 p square by 4 plus p square is equals to 1. Now from this 4p square plus 4p square is equals to 4 plus p square. From that, what is P? From that, what is P? Which is nothing but 4 by 3 under root. Correct, na? 4 by 3 under root. So P square come this side, 3P square is equal to 4. Therefore, 4 by 3 under root. What is this value? 2 by root 3. Therefore, what is this answer? B. How we have solved? So simple. They have given steady state output. Okay, I have taken steady state output. What is the signal? Input signal. This is P. It looks like a previous problem only. P times of that magnitude. P times of, this is the input ka magnitude. I want steady state magnitude. What is the steady state magnitude? We will denote it with A, na? It is steady state output. Generally, we will represent like y of t is equals to A into some. Suppose let us say sign you have given omega t plus or minus 5. So I need to get this. So first I need to calculate the magnitude A. If I calculate the magnitude A, I got this one. But already input is there, na? So this product of this, already they have given 1. So that means the product of these two is equals to 1. So I need to calculate simply the value of P. So that means if I choose in the value of P such that, I will be getting the steady state output as 1. Steady state output as 1, whose magnitude is 1. Got it? Yeah, please take it down. Now let us see another question. So now you see here, find the transfer function. They have given 10 by s square into s plus 2. S square plus 2. Input is sinusoidal, sin t. Input is sin t. Okay, find the steady state output. Y is equals to how much? General procedure, what we will do? Here omega is equals to 1, and what is its magnitude? We will write like 10 by 1 into root of 1 plus 2, which is nothing but 10 by root 3. What is the phase you got? Phase I can say minus 180 degrees minus, when you write directly, tan inverse of omega by 2. Omega is equals to 1, and you will get something, some let us say some minus 220 degrees something, approximately. What I am telling is approximately. So then you will write like output equation. You will write something A, this input with angle. Hai na? First write this and struck entire thing. This is where generally we will commit a mistake. Always such chances will be there in the exam. So this is actual procedure we are going to follow to calculate the magnitude and the phase to represent the steady state output. But actual scenario is, if you see, it is not a pole at origin, it is double pole at origin. Whenever, if you have note, if you observe in my lectures, I have clearly mentioned in RH criteria. So, or you can say any closed loop transfer function. If any double pole at origin is there, if any double pole at origin is there, then the system is unstable. This is a very important note where we generally commit a mistake. In the system is purely unstable. For unstable system, you cannot be able to find out the output because output is unbounded. Output is what? Output is unbounded. Output is unbounded. Therefore, you cannot find out the steady state output of the system because the reason is two poles at origin is there. I hope you clearly understand. Please write down this and struck off this so that you will never ever commit a mistake, and try to take it as a hint. This one, take it as a hint. Very, very popular question, because in TRANSCO and GENCO, if you see such questions are gives, majority of the people, if they miss the concept of this double pollet origin, they will definitely commit this mistake. So they will be in the out of race, because control systems is somewhat easiest subject than any other. So you can score more in this. If you lose marks in this, means nothing you will get any other subject. Okay. Now let us see another question.